Cecily has been working a lot in Dekalb County, and I've gotten to know Cecily over the years and consider her, along with Holly and a few others, as being the true leaders in watershed planning for the region. So look forward to hearing what Cecily has to share with us. Go ahead, Cecily.
I appreciate that, Scott. Thanks. I assume you guys can see my screen, right?
Yes.
Yes.
Okay, great. Yeah, so as Scott mentioned, I've been working in and around the Kish for quite a few years now, and generally I've dedicated my career over the last dozen years or so to watershed planning. So I think many of you know Steve Zimmerman, who we both used to work at Applied Ecological Services, and now we both work at Baxter and Woodman, but between us we've written almost 20 watershed plans, and more than half of those have been in Illinois, that all meet the 9 elements, and we'll talk about that a little bit more in a second. You have just this picture, this on the background of the screen here is actually taken, this is the Kish at the bridge at Russell Woods Forest Preserve near Genoa. So just a gorgeous spot on the Kish. So today I'm going to walk you through, and I can't see, it's hard for me to see the chat while we're talking, but if you want to unmute yourself and ask questions at any point, please feel free to do so. I'm going to walk you through a little bit of Watersheds 101, watershed-based planning, what it is, and where some of the existing plans are. I'm going to talk a little bit about our actual water resources and their quality in the Kish, some things that impact our water quality, and what you can do to help protect our waters. So what is a watershed? I always include this slide because you just never know who you're talking to, but a watershed is, think of a bathtub. It's all the area of land where any precipitation that falls on that land is going to drain to a single river or stream, in this case, the Kishwaukee River. And watersheds do not follow political boundaries. They follow topography. So they follow the land as it was carved by the glaciers and erosion thereafter, you know, millions of years ago. So watersheds come in all different sizes. On the right, that silhouette in blue here is the boundary of the Kishwaukee River Watershed. And the Kishwaukee is part of the Mississippi River Basin. Watersheds are nested, and they come in all different sizes. And the Kish is part of the upper Mississippi River Basin of the Mississippi. So just a little background on hydrologic unit codes, and basically think of an address for a watershed. This is a system that the USGS developed, I don't know how long ago, that basically gives a unique identifier to every watershed in the country. So if you think of the Mississippi River Basin, the HUC2, hydrologic unit code 2, represents 07 represents the upper Mississippi River Basin. So that is, you know, this is 07 of those basins. So and every time you're adding 2 digits, you're getting progressively smaller in size. So you know, the Rock River is I'm sorry. The smallest size is a HUC, or the smallest size we're going to talk about today is a HUC 12, which are the little gray outlines within this larger blue outline of the Kish. This number up here is this very southernmost HUC 12, which drains to the south branch of the Kishwaukee River, which drains to the Kish, which drains to the Rock, which drains to the Mississippi. So just an example, it's kind of like a big funnel. So this is a big overview of just the named streams in the Kishwaukee River Basin. So there's actually, probably 3 or 4 times the amount of streams in real life, but if I put them all up on this map, it's very hard to read. So I'm just using the named streams. And in the background, you can see those Huck 12 watershed outlines just for reference. So I'm going to kind of keep this map, and we'll see a couple different versions of this throughout. I'm not going to go into all of these, but again, this is the general outlay of all the creeks that drain to the Kishwaukee River. So what is watershed planning? It's a voluntary community supported approach to protecting and preserving streams and lakes and restoring habitat, reducing flood damage, and improving quality of life for people. The type of watershed planning we're going to talk about today is usually done at that Huck 12 scale, maybe up to 2 or 3 Huck 12s at a time, but it can also be smaller than a Huck 12. So specifically the type of watershed planning that I focus on is it comes out of Clean Water Act Section 319, written back in 87. And it is dedicated to controlling non-point source pollution, which is any pollution, water pollution that comes from anything but a pipe or permitted source. This program is a federal program that is delegated to the states. So they all have to meet a certain federal bar, but then within that, each state can kind of handle it a little differently. It encourages the development of these watershed plans and implementation of the practices recommended therein, all dedicated to improving water quality. It is a voluntary program. It is not enforceable, meaning like there are there's a regulatory side, like permitted sources where you have to have a permit and meet that. This is all voluntary, so they usually use funding as the mechanism to try and get you to participate. These are the 9 elements. So when I think it was back in 07, EPA wrote a 200-page guidance document of what is necessary in a watershed based plan, also sometimes referred to as a 9-element plan. Or a watershed-based plan, 319 plan. So there's 9 elements that you have to hit. So some of the things you have to do are you have to identify the causes and sources of impairment, or what are causing our water quality issues. You have to do some modeling to estimate where those pollutants are coming from. You have to propose recommendations, both like policy and on the ground recommendations, like restoration projects that can improve water quality and identify the critical areas or the areas that are most important that we address. You have to identify technical and financial assistance needs, complete basically an education outreach program, how you're going to get the word out about the plan. You have to identify an implementation schedule, when things need to get implemented and over time, and describe milestones so that people can track how the plan is being completed over time. And you have to estimate load reductions from pollutants like nitrogen, phosphorus, and sediment. So you have to estimate, if we were to install all these practices that we recommend, how much water quality improvement you can get. And then again, how to monitor the plan over time. So why do you want a watershed plan? First and foremost, to determine the health of your watershed and the water quality. And it will basically pave a pathway for what you can do to restore water quality if it's not meeting standards. It's going to give you a bunch of actionable projects and recommendations in the plan and prioritize those projects for funding. And we'll talk more about the end. There's lots of opportunities to get funding for projects. The planning process helps build community support for implementing plans. And then again, gives you guidance on implementing and monitoring plan progress over time. So just a little snapshot as we're, this is speaking just strictly as Baxter and Woodman. We have like basically a planning process that sort of distills a method of hitting those 9 elements in a pretty systematic fashion. It usually takes 1 to 2 years planning process. And the very first thing we're going to do is a field inventory where we go out into the watershed on the ground and complete a bunch of data sheets and try and take a look at all the streams and all the land area in the watershed and look for where we might install recommended practices. Things like stream restorations and wetland restorations. We also have to do a bunch of front end work trying to look at the existing conditions on the ground, also known as a watershed characteristics assessment. So all sorts of things, topography, land use, demographics, you name it. There's a ton of stuff in there. And then we're going to identify causes and sources of impairment. We're going to host a goals workshop, and we actually just had one not a month ago, for a couple weeks ago, for the Central South Branch Kishwaukee, which I'll show you in a minute, where to determine goals and objectives in the plan. We'll identify critical areas and reduction targets, that action plan of recommended projects, and then again, a way to evaluate the plan over time. Typically, meetings are held every other month over that 1 to 2 year planning process, just as a way of, it's our opportunity to basically both gather feedback and present back the information that we're discovering as we're going through the planning process and hitting these milestones. This is my representation of a map that CMAP usually keeps updated of where watershed plans are being completed. I know Holly's in the midst of updating this for us. I'll also note that I wanted to keep the Huck 12 boundaries, not make them any smaller. So some of these watersheds are the actual watershed boundaries of the watershed plans, particularly for I think this Lawrence Creek, are a little different. This top lobe is not here, and I think we're missing one for Madigan Creek that's about here. But this is an overall representation of where watershed-based plans have been done and in the Kish, and when they were due. And I'll just note that when they were written is important in that in Illinois, IEPA, if you want to go out for funding, 319 funding, you need a plan that's been completed or updated within the last 10 years. And if it's outside of that, every 10 years or so, they ask you to update the plans. So it looks like we have a couple that need to be updated or actually need to be updated within the next couple years. I hear somebody chime in. No. Okay, so taking a look at the quality of the existing streams, IDNR houses they have basically biological surveys that they do. Admittedly, this data is dated. I think the most recent of this is from 2007, and hopefully one day they'll get funding to continue this work. But in the meantime, The streams that are highlighted in green basically shows some combination of either being biologically significant streams, or they have a diversity or integrity rating of A. So the IDNR looks at diversity, which is the number of different aquatic species found in streams. And then they also look at integrity, which is the ability of a stream to support organisms. So essentially, it's another way of looking at water quality. There's like biological data and chemical data. And this is just an example. I know that parts of the south branch of the Kishwaukee River, where I've worked in Dekalb, are listed as unique aquatic resource by IDNR. They're rich in aquatic species and native mussels, some rare ones. They've got diverse native fish and mussel populations, all of which rely on clean water and clean habitat. Water quality in Illinois is monitored by IEPA, the Illinois Environmental Protection Agency, and US EPA requires them to assess and report on their waters every other year. Essentially, they have to detail whether their streams meet water quality standards or not, and lakes. And if not, what is causing those issues? And if a stream is not meeting the biological or chemical standards, it's considered impaired. So this is also a representation of one of a map that IEPA houses, but according to 2022 data, the streams that are highlighted in red are impaired for one reason or another. And some of the most common pollutants we see are, or impairments that we see are phosphorus, nitrogen, sediment, and E. coli, actually. Okay, so sources of pollution. As I kind of mentioned before, there are point sources and non-point sources. Point sources include anything that is a permitted or a discrete source. So think wastewater treatment plants, industry, and construction. IEPA manages permitted sources, again, through permits. So they will meet with these guys and determine how much of various pollutants they are allowed or permitted, literally, to discharge into waterways. So we acknowledge these as part of the watershed planning process in a 9-element plan. But we're really there to address non-point source pollution, which is everything else, like I said. So again, that's anything that does not come from a pipe or permitted source. Typically, we're thinking cropland areas, stream bank erosion, urban areas, that sort of thing. Overland flow. And as I mentioned, some of those things that can affect water quality, first and foremost, is nutrients, which are nitrogen and phosphorus. They are necessary for plant growth. We obviously need those in order to have, most of the food we grow and eat. But those same nutrients can be very detrimental to waterways and aquatic systems. So phosphorus, for example, when that gets into streams, the plants are not able to take it up. The aquatic plants are not able to take it up at the same rates that terrestrial plants can. So, and though that excess nutrients then gets eaten up by, basically causes algal blooms, and accelerated plant growth, which reduce oxygen levels and can lead to fish kills, and are generally what are driving the Gulf of Mexico hypoxic zone. Sources of nutrients, agricultural row crop runoff, stream bank erosion, because those nutrients are bound to some of those soils, and as the soils slough off, they're dispersed into waterways. Lawn fertilizer, failing septic systems, and permitted sources are all sources of nutrients. Sediment is another cause for concern in water quality. So if you take a look at the stream shown on the right, you can see it's got that sort of chalky brown, sort of looks like chocolate milk quality to it. And I've actually just seen that with all the rain we've gotten nearby me in the last few weeks. Those are sediments that are literally being suspended in the water column. This reduces light penetration and oxygen levels, can cause clogged fish gills and makes it harder for them to be able to find their food. These sediments can also settle out into streams and lake and cause us to need to dredge. And they can also reduce the size of the floodplain as well. Sources of sediment are, again, stream bank erosion and removal of vegetation from banks. That vegetation holds the soil there. Construction practices, site grading, land disturbance, agricultural row crop runoff and soil loss, and increased impervious surfaces can all contribute to sediment. And just to talk a little bit about impervious cover increases. So, you know, as we're urbanizing some of these streams, the impervious cover increases and leads to stream habitat degradation. And those streams lose the ability to compensate for pollutants and sediment, and also leads to temperature and flow increases. And there's some examples of, you know, streams in various states of being impacted by urbanization down at the bottom. And lastly, fecal coliform is also, and E. coli are an issue in some of our waterways. They are, so fecal coliform and E. coli are indicator bacteria. They're used to show like a representation of pathogens that might be in our waterways. They are a possible health risk for recreational contact, like if you're paddling and you accidentally ingest some of it. Can also cause cloudy water, unpleasant odors, and increase oxygen demand. Essentially, this is basically animal or human waste in the waterways. So sources are agricultural, animal, or wildlife waste, manure application, failing septic systems, and permitted sources such as wastewater treatment plants as well. So to address all of our water quality issues in a watershed, one of the things we have to do as part of the planning process is identify priority areas where we can restore our waters and prioritize them for funding. So this is an example here of a critical area map, project area map that we did in the upper south branch of the Kishwaukee, that shows all of the critical area, stream, wetland, detention basin, you name it, all the projects that we're recommending in the whole watershed that are considered a critical area. These are typically like the areas where we can get the most bang for our buck, so to speak, and are also ranked as the highest priority for funding with IEPA. So again, as part of the planning process, we develop an action plan. It usually comes in two pieces: programmatic measures, which are policy and policy updates. We usually do an ordinance review looking for ways where we can have broad effect over watershed conditions, and the site-specific measures, which are those on-the-ground recommendations that we would have identified during our field inventory. And they come in all sorts of different types. So some of the policy recommendations we might look at, again, plan adoption and implementation is always the first thing we start with. We want our communities to adopt those plans and start using them. We usually do an ordinance review and suggest updates that communities can do. We look for other policy recommendations on the green infrastructure network, sensible salting programs like McHenry County has, stormwater management, native landscaping and natural area restoration ordinances, pavement alternatives, and things like banning coal tar sealants. We also recommend that communities are maintaining their septic systems and educating those rural landowners with how to maintain these over time, and provide guidance on how they can do that. We also recommend conservation design and low impact development. Typically, that's where we're going to cluster development within a property so that it's away from natural resources that might already be on site, such as wetlands or streams. And it's basically a way of maintaining density while preserving those natural features and the ecological the ecosystem benefits on site. We also recommend using pavement alternatives where we're able. These allow replacing, we can use, permeable pavers or permeable asphalt. Permeable concrete. They allow water to infiltrate and recharge groundwater. They also reduce stormwater runoff. We can use these. These are especially great in areas like forest preserves or parks. And they can reduce sediment, nitrogen, and phosphorus by 90, 85, and 65%, respectively. Some of the site-specific actions we might recommend, and again, these change from watershed to watershed, but most commonly they kind of fall in these big buckets. Stream bank and riparian area restorations are almost always a great bang for your buck. You want to target where erosioning is happening and address that. Agricultural practices, wetland restoration, and actually mitigation banking, as we kind of talked about earlier. Detention basin retrofits, natural area restoration and maintenance, and things like rain gardens and bioswales that are typically more educational projects for the community. Just a little bit more about stream bank and riparian area restoration. Basically, we're going to use natural channel design to try and improve the quality of the habitat in stream with pool and riffle complexes. We're going to stabilize the banks. And again, typically as much as possible, we're going to use bioengineering techniques where we're stabilizing the soils with natives and then, hard armoring only where necessary. And we want to increase the buffers wherever possible and restore those buffers on those streams. And this is, again, one of the single most effective at reducing pollutants across the watershed at 90% reduction of sediments and nutrients, both nitrogen and phosphorus. Wetland restoration is another great one for improving water quality. This is basically returning wetlands to where they're hydric soils. This can be used as part of conservation design. And again, as mitigation banking, this is basically the method that they would use. And you can get quite a bit of bang for your buck in terms of improving water quality. We also recommend in more urbanized areas, detention basin retrofits. Detention basins are typically, installed to meet essentially, flood requirements with a few tweaks and, restoring the banks and maybe including some wetland plants at the water's edge. We can actually get a lot more water quality benefit from those basins. We also recommend street sweeping, especially this is great for reducing sediments in the watershed. And at the very end of our watershed plans, we're going to give you a big table of all the recommended actions, site-specific actions that we've identified. They are 100 to 200 projects, might be in any one watershed plan, and it gives you all the information you need for basically to go out and get funding for these projects. So what the existing conditions are, what our recommendations are, the pollutant load reduction expected to be gained by installing the practice, who you can go to for help to install the recommendation, and a cost estimate that you can use again to go out and get funding. Sorry. And again, the whole reason we do these watershed plans is to try and help bring funding to improve water quality and habitat in the watershed. So just provided a list here of potential sources of funding in the watershed. I do want to note that most of these are targeted at installing implementation practices, but IEPA through their 319 program funds both restoration and planning. And I did want to mention that so IEPA section 319 is open right now. It closes on May 15th. I spoke with Jeff Edstrom at IEPA about a week ago, and it sounds like the latest update is the Green Infrastructure Grant Program is looking to be open sometime in the next couple of weeks and perhaps close the middle of July. And then I think they're going to open 604B, which is a watershed planning grant program after that. And then they do look to open 319 again towards the end of the year and hopefully get back on track. They've been a bit behind over the last few years, but it sounds like they're looking to catch up all in the remainder of this year. So how can you protect your waters and the Kishwaukee? Again, continue participating in meetings like KREP and other watershed planning processes if they're going on. Let's develop plans where we're missing those, especially in some of those waters that we already know are impaired. Encourage plan implementation and find out what projects near you need funding, and let's figure out a path forward, moving forward to get them implemented. So that's all I have today, guys.